of the weekend. I'm going to be joined up here by Max from Boron, who gets extra credit for being early, and the rest of them I had to chase down. So we're going to but we've also got John from Proper Printing, who's going to be joining us. Luke from Big Tree Tech, and Indy Glegal goes in here earlier presenting from Full Control XYZ. And come on up here. So we're very casual how we go about doing things.
I think I found it.
Any other buttons?
You get to page 5.
The topic at hand is the future of 3D printing. Specifically, I said if we were to envision, say, 25 years into the future, because that seems like a reasonable time.
25 years.
Yeah, 2050. But we can also talk about, there it is. Look at this, look at how a plane comes together.
I wasn't glad.
I am still 3 minutes. Yeah, we're still early. Yeah, so I thought it's a very casual affair. But I have always been a real big fan of futurism, talking about that kind of thing. And we've all been in the industry now for quite some time, some more than others. But we've seen a lot of change already. And so I guess the premise of the conversation is, given all the things that we've seen, what is it that we are both most excited to see looking into the future? What could we be terrified to be saying? Do we have a 3D printing Skynet situation in our hands we have to worry about? Hey, am I right? No, you're not. We've just been kind of shadowing earlier.
So, have you keep?
My job as a moderator is actually to try to keep you guys talking, but I was just kind of setting the stage a bit. So I did in the pamphlet talk about what might 3D printing look like in the next 25 years, but we're not saying only looking at who knows that far out. If we're just thinking about the future in general, the reason I picked each of you guys is I think you bring a unique viewpoint in various things, whether it's in business, in academia, and in software, having gone from, obviously being a professional engineer to a full-time YouTuber, what that experience is like, and then of course, now it's one of the most relevant parts of the entire, open source movement in Boron as the next generation of kind of that. There's a broad array of insight here. So I'm going to let each of you just really quickly just give us a quick who you are, for anybody that might not know, and then we'll dive in on just some things around what the future may hold for you. So Max, why don't you start us off? Of course. We'll be on the spot. Yeah.
Hi, I'm Max Solon. I'm the founder.
Project, because I think those are
Cool. Hello. Everybody can hear me? In the back? Cool. There we go. Hi, I'm Max Solon. I'm the founder of the Boron Project. Been doing this for about a decade now, as of this year. So, it started off as a company. I did give a talk at the very first SMRRF about the whole history of Boron. Basically, you can go look that up. The TLDR version is, it started off as a company, then I folded the company and just open sourced the entire design and everything, and it's been going strong ever since. We sort of blew up in 2020 because everybody got locked in and said, oh, hey, that Boron key that's been laying around, I should build that. We did release a whole bunch of printers that year because, again, we also all got locked up inside, so we had a whole lot more time in the shop to work on printers. So now it kind of became the 500-pound gorilla of the open source industry, the hardware industry, where we're able to push the boundaries of a lot of what hardware can do or what software can do without being impeded by the fact that if we were a company, we would be cannibalizing our own products, but we're not, so we can do whatever we want.
How many people show hands have built a Boron at this point?
Any of them.
All right. Nice. This guy's on this. You built one too.
Still in the box.
You still know the same. Maybe it's not. You're up.
My name is John Shore, and I run the YouTube channel Proper Printing. And on there, I experiment with 3D printing. I modify 3D printers in a way that is not supposed to be done. And I try to print things that I haven't seen them before in a way that has to be done before just to see what happens. And I think what's interesting about innovation and doing that in a YouTube video is that I don't have a product that I have to sell. So my selling point is it must be a interesting video that people want to watch. So that gives me a lot of freedom where I can do the most insane experiments that doesn't really make sense, but because of that I find some interesting use cases often. Also, by bringing in the audience, it's there's so much feedback about it. What can be done with suggestions. So I didn't expect that from the beginning how much innovation can be done by using YouTube as a platform. So that's what I try to focus on.
Yeah. And how long have you been at it now?
Full time, it's 2 years. I started the channel in 2019.
What right?
Yes.
Nice. Amy, can you hear me on this? Good. So, hi, I'm Andy. I'm a reader and editor manufacturing at Loughborough University. I started 3D printing in maybe 2012, 2013. Okay. And then that started very intricate paths, and then I moved towards mechanical testing in around 2017. So I really specialized on the bond between layers and the mechanical properties of that bond. And the things I found from that then have been moved towards robotic printing and toolpath design, where I found that the geometry was the most important thing. So then that's when I developed software to actually design that geometry. So I've released open source software. If you've ever seen a sphere printed on the top of a little pole, that's thanks to me. And then various other design challenges. So the things I've tended to release public are things that are very simple examples of stuff you can do, you might not think to do normally, just to try and raise sort of just the awareness of what could be done with some bottom up, as I call it, from Beth. Luke, I work for a company, PQ Big Tech. I guess my first exposure to 3D printing was probably around 2000. At that point, it was just out of the means to an end. I was working as an electronic engineer. We needed to rapidly prototype the closures of parts that we were making, and that was really a technology that we used. And at that point, and how to be expensive, massive to not be successful for me at that. At some point in between then and now, throughout 2018-ish, became more than just a means to an end. I became fascinated with the technology. So it became this node sitting in a room, tinkering with bits and pieces, or building warons and whatnot. And that's how I got in touch with the company I work for now, bought a whole bunch of this stuff, wrote up a bunch of guides on, got contacted by the CEO and said, hey, one day you're arranged. You sort of wrote up something. Here we are. So I guess, my insight is we kind of do a bunch of stuff for the Boron project. We look at videos that John makes. We get a little bit afraid of what he's doing, but we'll take inspiration from it too. And then we see what the market's interested in, what's cool. We can't make products. And then again, also we look at some of the really far-end stuff that's being done and see if maybe that can be integrated to some sort of a upgrade or add-on for the printer to make the overall user experience a little bit better. So and we're really obviously happy to have you here, but obviously Big Tree and DQ has had its hands. A lot of times you might not even realize like your guys' gear is at the heart of a lot of those things. So you've done the Death Racer kit, and you said a lot of the Boron stuff is stacked with Big Tree hardware and stuff. And I'm sure there's all kinds of stuff we don't even know about coming down the pipe as well. So that's awesome. So. All right, so to start us off talking about the future, Max, I'm going to pick on you because with your history in open source and how relevant it is to obviously this foundation, this event, and thinking about the origins of open source and the importance of like how that got us to where we are. How do we all see open source continuing to stay relevant and playing a role into the future, or do we think that it will?
We're talking specifically open source, in general, software and hardware?
Yeah, I would say either because there's definitely applications.
Right. Well, open source in general, I mean, I've been in software industry for 25 years at this point. And really open source software is what drives everything you do on every device right now. It's the backbone of entirety of the internet, basically. And same for 3D printers. If the patents didn't expire in 2010 or 2012-ish, we wouldn't be where we are today, because really closed source stagnates development, essentially. Because usually it's locked up behind, company patents, and then company lawyers, and then companies' finances. So they have no motivation to just tinker and improve and release better things to the public. Whereas being open source, it provides us both with freedom to completely innovate in any direction that we want. And when you get 10,000 nerds in one room, you're going to come up with really, really, really stuff. But the second part is it allows us to collaborate completely freely without the need for worrying about patents and all that other stuff. It allows us to, I guess, freedom of expression in a way, just like you did with your YouTube channel. When you get a whole bunch of people talking, they all have very, very different backgrounds that they come from. We have a whole bunch of hardware engineers, we have a bunch of software engineers, we have a bunch of robotics engineers. When you combine all of that together, and then we have people that do documentation professionally. So when you combine all of those into one community, and they all kind of driving towards the same goal, you kind of come up with really amazing stuff that you wouldn't have come up with if this all was locked up behind the companies.
Sure. Luke, as a company that's coming in, obviously designed to make money around this, what do you see the role or the responsibility as a business in being good stewards to open source, but at the same time, how to provide that technology and enabling projects like Boron and other things in the future?
Yeah, that's a constantly shifting line in the sand. I think you've got, if you ask that question 4 years ago, everything Repkord did was open source. The hardware, the software, and that really was the community 4 years ago. Of course, history repeats itself. So can we draw an analog to something that's come before? Yes. You look at really where computers came from. In the early 80s, as they progressed, really it was all open source. It was a bunch of geeks putting things together. A lot of the software was, and progressively moved to where some things closed. And where they did close, the software was also, almost the hardware was closed and the software was closed too. So for us, from a business standpoint, some stuff is not closed, right? And we connect is a lot of them do stuff that closed, and that's their choice, and they're entitled to it. When we make products for those machines, we tend to close the hardware and software, purely because the amount of R&D and investment that goes into it is tremendous. And we were just sort of handed over. We've paid those school fees, and it's possible that some of them come in, and it's difficult to patent that sort of stuff. That from happening.
Yeah.
So we were just giving over. But where it's involved in sort of the open source community, anything we do there remains open source in terms of software and hardware. We just released the VDE, which is a multi-coding pattern. It's taken us almost 2 years. The insane day of all the hardware and software would be open source. So yeah, horses for courses.
Amazing. Andy, on the software side of stuff, I know you've played with the hardware stuff too, but I'm gonna make you our software guy for the sake of this discussion. You're comfortable representing that?
Yeah, that's good.
Okay, good. So you mentioned a lot of what you do is open source. We hear oftentimes in 3D printing that we like to talk about, well, technically we're still at 2.5D printing because we're going to layer at a time. Obviously, what you've done with full control, trying to push the envelope with non-planar, multi-axis, those are things that I think a lot of us are like, man, that could be really cool, but they're very limited by the software that we need to actually get us there. So how confident are you that that is going to be there, and can it still be open to people, or are we going to see companies locking it down just because of the investment required to get that specialized toolpath that you've heard, multi-axis found there?
Yeah, I think things will go in a positive direction in this field. I think there's genuinely maths is really doing everything out. CAD is really bad for maths because when you do, say, a round-ended rectangle, you're defining core points for a rectangle, and then a center point of a circle, and then adding the circle and saying cut off this bit only for 90 degrees for the circle. and then do it for 4 more. It's a lot of instructions there. Whereas a mathematical definition of that with a center point and a radius that's going wider, narrower, that would be a few characters. So that sort of language, there's nothing proprietary there. And with language models, if they are very good at maths and code, so then this way it's all been developing over the last couple of years, then the design capability, it's now super simple for me to go in and say, create a squiggly wiggly XYZ path that does this and that, and it'll do you bonkers that of maths. So it'll put in some fluctuating noise functionality, and it'll do stuff I've never even heard of and don't need to understand. I can check if it's correct or wrong, but don't need to understand. So the proprietary value there is kind of reducing if maths becomes more dominant, because there's less of proprietary there. So the other thing there as well is if you go very proprietary, the training data that you'll have before your for your software aspects, with most likely interacting with more dynamic software going forwards, it's kind of generated on the fly. That's going to be kind of limited and only moving your pace. So that's going to put some, similar to the things I was saying about development gets harder and less work rewarding. You don't get the other things, the other people's benefits. So I think there's some positive aspects there. The negative side for sure is that this is putting the power is going into the large language models and how good it goes, which might be a much worse thing in the end. What is that?
Yeah, that's really interesting. So how much of it do you think is a function of it just like the math being difficult versus just feeling intimidating and not accessible to individuals?
I think it's difficult because as soon as it's not difficult, you just want to go more, and you just keep going until the maths is beyond you. So you just get empowered, and you'll always go to your limits. So I think the maths can do so much in terms just far more than you could ever think of for geometry. So, but what you can describe want, tolerances, real math, not just lampshades, right? Real tolerances for engineering. And the fact that radii are so prolific in design. It's only because it's easy for a human to design them, but actually there's nothing to say they're better than having a corner that is slightly rounded and then more sharp and then but it's not a smooth round arc anymore. So it probably perform the function it's supposed to do a lot better if you're choosing that versus thing. So I think it's always going to be just more than you can actually understand mathematically, because people just once you get that formula, you see the geometry and be like, I can't make that a it don't.
So we're really trusting. It sounds like we're really starting to trust the machines to do a lot more of the heavy lifting. Can you just give us a sense of context of like how rapidly you feel like you've seen this develop just in the last few years and what the trend looks like maybe?
Yeah, this is really hard. So 4 years ago, the software engineer that I worked with on full control, is semi-retired software engineer, who's just seen it all in robotics industries and everything. He's always been passionate about them and said they're great. And I first got in, I was like, I don't think it's going to work at all. And I said, create me a function to do like a rectangle with the width and height line. And then it would do that, and I was really impressed. And I thought this is far beyond what I thought it could possibly have done. It's 6 months before. And then a year later, could do more complex things like a spiral or something. And then literally a year later, it's looking at all of the files in my probably 100 files, examining them, pulling out a summary of them, finding errors, and writing edits to make 10 files all at once. And that was maybe a year ago. Just compared to a function for a spiral, it's just incomparable. And then more recently, it's switching to a thing where you say what you want, and you don't even look at the code. You just test really carefully that it is doing what it must do. And the intelligent thing there is getting a way to check that it is correct. So I think in 10 years from now, the way we code and stuff will just be completely unrecognizable. Maybe it's not.
That's really interesting. John, I want to jump over to you because I would argue, having worked with a ton of creators over the past few years and whatnot, that you have one of the hardest jobs sometimes where you're trying to find the intersection of the engineering, the understanding of the technology, and then the entertainment side in a space that is very desirable. You know, you talk to any kid coming out from this day and age, where you want to be an influencer, or be a creator, you know, a communicator, and know and understand something and do it professionally as an occupation, and then to be able to teach and entertain people are very different skill sets. So, how have you seen the industry change? And then, as a creator, are you concerned with the future there still?
It's a very fine balance between entertainment and information. And I see when it goes too far into entertainment, then it's quickly becomes shallow. But if you go too much into information, then it can become boring. So it's always an interesting balance there. So what I try to do is at least people who are watching video needs to get something out of it. Mostly it's integration, and it's perfect comment to come from my friend Janos.
Do you want me to answer it?
Yeah, can you ask Janos? Janos, this is the best.
Hey, Janos, you're on the panel right now. Can we call you back later? Yeah. Okay. Bye.
So yeah, it's you need to have some bits in the video that people can get inspired by, or learn from, or entertain. And it's not just one or the other. So it's difficult though. So I see that if I tend towards to go too far into entertainment, then the video doesn't perform as gone.
Yeah.
So yeah.
Yeah. Okay, so we've got about 12 minutes or so left, and so we've talked about some background, we've had some context, we have some insight from across there. But if we were just like wax philosophical about what the future might hold, and let's just start with things that like we might be excited about. Let's try to stay positive here. Okay, like the things that really just get you out of bed in the morning in terms of something you saw. It could be a video, it could be something you're working on personally. Why don't you? What do you got for us?
Games.
Tell it to us.
Yeah. All right. So I don't know if you've seen it. Something that just really excited me. FDM's kind of become the de facto when people come to 3D printing thing. It's mostly FDM, right? So I really enjoyed seeing that flight next, the gel effect, silicon based printing. Now that's a really cool technology. It can do things really fast, very precise. And with the sort of technology that's completely outside, it's the extrusion based, but outside of the norm, the norm. Right.
Yeah.
I'm excited to see, obviously, there's patents associated with that. And as Max said earlier, a lot of innovation and sort of drive happens with those disappear in a few years from now. Well, it's a few years. At some point in the future, let's see where that goes. Could that be brought into the consumer domain? And we could be producing stuff then that we just think is completely out of reach.
Yeah, absolutely. Let's talk about Max real quick. You could have had the luxury of like really being where the rubber meets the road. Sometimes you see what people are committing and how they're auditing and stuff like that. So is there anything in the project currently that you're like really excited for? I mean, we've seen variants of like different fed sensing and all kinds of stuff. And surely, can you even tell us, or is there? It's open, right? So
yeah, a lot of the stuff that you see is the art mods. And there's like a lot of work that's going into, like, for example, D3D working on improving flow rate so you can print faster, you can get filaments faster. There's a whole lot of stuff that just print speeds of the stuff. But if you really like zoom out and look at the future, I think where the really exciting parts are going to be improving usability of the carriers. Like you've built a machine. What can you do with it? Is it easy to use? And a lot of it comes from, if you look at Linux 5 years ago, right? It was very super powerful stuff if you knew a command line, but like the GUI just wasn't there. But now it is. The UI projects have come around. Basically, you can actually install Linux and use it as a replacement for your Windows machine. I think what happened with Bamboo when they came on the market is you can buy a machine and basically get printing in about 20 minutes, and you're there.
That's
Like, we're not there yet as an open source project because all of us are super geeks. Like, we want to go into the command line and start doing stuff. But that's not really the general audience of for people that like get into 3 and get taking stuff. I'm not saying that we need to be where Bamboo is because completely different audience for us. But where I see the project going is continue to develop the hardware and push the limits on the hardware side of things, but like also work more on the software and improve that side of the things where it's more accessible for people. It's just nice to do it. You know what I mean?
Yeah.
John, you've done one of the projects you've done more recently, and we're seeing. I don't know if it's fair to say we're living in an age of tool changing, but tool changing definitely seems to be in the zeitgeist at the moment.
Yes.
You did that really awesome customization of the Excel platform with your proper extruder, which was really cool. What are your thoughts on is tool changing like something we're just going to see more and more development with? Like, as new companies are coming, and is that the path? Like, are we just kind of like imagine it's just what's in front of us right now, or do you see that as a scalable?
Yes, I think that's actually in the future. Not per se tool changing, but the tool changing we know now is just multiple polymers. And we see now, for instance, with filament 2 with silicon, that there are finally some non-polymer 3D printing being done. Well, we have chocolate, of course. What I think that, especially combining materials, totally different materials, to really make use of these of their properties, will be done more and more. When we actually make use of the fact that it is additive manufacturing, that we can, during making the part, manipulate it by using different materials. So that's also why I started modifying the Prusa XL. Is I've done a video in the past where I print it with resin, for instance, through a nozzle. I extrude that as a tool on the XL that can print resin and combine it with a polymer like or electric. So I think combining the weirdest materials you can think of on a platform like the XL to discover new possibilities there. There's so much to discover still.
Well, and then how important is it to have platforms that allow us to develop on top of them? Because I think commercially we're seeing like this tendency to kind of close up, and like if we're all agreeing that innovation oftentimes is happening because of all of these things, like I think we really underestimate like the value of like having projects like the Boron or having companies like Prusa that tends to encourage open development on that plastics. Coming.
Yeah, it's you see the both paths, like you said, that use this path of usability, but you need to continue this path of open development and being free to do whatever you want. So it makes sense that you have these two different worlds, and it's nice to make use of a printer that actually works. But besides that, to have a platform on which you can experiment. They can live side by side, but
Andy, you brought up LLMs in your talk earlier, and even just did the conversation earlier. Can you, like, admittedly, that is not my forte whatsoever, but like, are there things that as you've been working that you've been like, this is really cool. Like, I have to do more and more of this. Like, and is it the scale? Like, what is exciting about that that's really going to enable some of that change you were talking about earlier?
Yeah, I think we are going towards hardware. I think that the way the coding just massively changed with language models over the last couple of years. I think the next steps will be towards them being able to get more physical awareness. So that they work out the coding because they can check. They do a function, they run it, they see if it works, they realize it doesn't, they get an error message, they know which bit didn't work, and they can iterate. If they then can do that in real world with canvas and inspecting stuff, this is going to be driven not by additive manufacturing, but all by robotics in general and stuff. But now in the additive field, in custom hardware, which part-specific configurations, or really are often moving towards such dreams of mass production type stuff, where you really would have justification for a really custom hardware, really custom tool paths to make parts for variants of parts, loads, and make it cheaper than injection modeling for much, much higher quantities. Look at that. But I think the language models being able to design weird custom real world stuff, right? The check printing, like as it's going based on the design, be that deceit to the interesting stuff.
And maybe for those that don't know as much about it, like, can you just give us a quick distinction between like what the work that these language models are doing and then what we've seen like in CAD with generative design tools where, you know, you're giving it a set of constraints and then it's making a suggestion based on, you know, I want the lightest weight or the, you know, whatever the constraints might be. Like, are they the same thing or are they completely different pieces of software? Like,
Yeah. So no, really completely different. So there's the ones in CAD, they'll take an object, do some stress analysis, see where the stress is the highest, try to reinforce that, see where there's waste of material not being loaded, get rid of that or make that more porous. So that's really a sort of mechanical design optimization. And the language models are just dumb letter generators and literally just do letters after one another. And I talk how much I love them, and I absolutely hate them as well and get infuriated by how bad they are all the time. But that's my fault as much as theirs, like asking too much of them and stuff. You'll get there. But they're just generating the letter that seems right for that time. So how they go from a camera image of a robot to the next letter in the word that is the result of the code, it is just weird, like pattern recognition type stuff. But if there's enough data there, then obviously the pattern recognition makes the right letters and space characters in sequence. So really a strange, dumb, uninformed process that just works with the flow.
I'm glad you brought up like actually starting to turn physical robots loose with some of this stuff, because like that paints that dystopian picture of like, you know, Skynet, Terminator, like what happens when we just like give the machines too much control. Are there things that you guys see that like are things that we need to be more mindful of or concerned? Like, is that just too far into the future? Like, what's the negative end, or like what do you think? What do you see that's a trend that's happening that we may need to be maybe more cautious of? Any thoughts?
Since that, I mean, yeah, Isaac Asimov was writing about this sort of stuff years and years back.
Sure.
And he, you know, envisioned principles into
The laws
exactly. I imagine we'd go the same route if we are going to empower physical things with the ability to think per se. We'll build some guardrails and do it. I think more than anything else, in terms of AI and how it's going to affect the industry, but more in general, it is just the effect that it may have on people's, like that thing is the to get, not what it's going to do to us, but just where we're going to be in 5 years. It's huge for
Yeah. You guys, this is fast. I swear we could go all day about this stuff. I really love this stuff. I would really encourage you guys out there. I'm sorry we didn't have time for like questions and stuff, but please approach these guys. We'll all be here all weekend, and we love having these kinds of conversations. Round of applause for the panel.